Okay, so then I think we can move directly to the Q&A session. We have some time for this now. So I can go through the first question that were raised, and you can ask more. So we already have at least 3 questions. So if I start by the first one from, sorry, I cannot see who is writing this. Okay, Dia. Thanks for the presentation. Would you say something about quality of wind and wave measurement using different tools? You have wind from floating LiDAR, but not wave. Why? So we haven't done a cross comparison between the different measurement sensors that we have. One reason for that is that it's quite difficult to achieve this within tropical cyclone because, as you may know, they are very small weather system, and the wave field and wind and wave field are varying very quickly in time and space, meaning that it's very hard to compare sensors together because they need to be very close. What I can say about that is, which is not exactly replying to the question, but just to extend a bit the discussion, is that we found very interesting and useful the data that are directly inside the tropical cyclone, the sensors that are directly inside the tropical cyclones, as for instance the Kaya data that are provided by the Hurricane Hunter, the aircraft that crosses the eye of the tropical cyclones. Also the sail drones are very useful, and also satellite observations such as synthetic aperture radars that are able to collect information within the tropical cyclones for wind and wave. And regarding floating LiDARs, yes, you are right. We did not use the waves from the floating LiDARs. We could have to check for which tropical cyclone we have this wave data, and you can incorporate it to the different data set that we have and to the model validation exercise that we are conducting. The next one was from Hélène Pinault. With the method and implemented tools, is it possible to get the directional univariate or joint extremes? So we haven't done that so far. It could be something we could do in the next project, depending on the priorities set by the industrial partner of the project. But right now, it is not the case. We do not have access to that. We could do that with the wave-watch tree model and possibly the CoolGSF model as well, but we haven't done let's say the analysis. I think we have the material for it, but we did not do this analysis. But I guess we have the material for this. So if I go up, next question is by Andreas Thorsen. Do you extract the extremes contributed by extratropical cyclone directly from RF5, or do you apply some post-processing and or modeling of the wind wave field for the event as well? I think this is a very relevant question. And behind this question, there is, I guess, the fact that it is well known that RF5 tends to underestimate extreme events, either tropical cyclone events or even extratropical cyclones. So right now we are using RF5 as it is. We could rerun, let's say, the most extreme storms with a more advanced solution with, let's say, a tuned wave tree model for extreme events, and let's say, update the RF5 with that. Possibly there are also already work being done in the literature, but right now we are using directly RF5. But that's a good question, and we should think about it. So there is a question then by Gauthier Melman. What type or level did you use? How much? So it's about the SAR data. How much processing did it need, and did you validate it against external data? So here I'm not the expert about SAR data, but we were lucky enough to have international expert in the team, especially Alexis Mouche from Ifremer and Bertrand Chaperon from Ifremer, who were guiding this work. And we had a PhD student called Clément Pouplin, who worked a lot on this data as well I think it's the L3 level, but maybe I'm wrong. Maybe I think Bertrand was in the room. He can correct me if I'm correct, if I'm wrong or not. And they had a lot of experience with this data, and they did a lot of validation against external data to make sure the data are the best possible. They are actually developing the algorithm to retrieve wind information from the STAR data for the European Space Agency. And I can connect you to them if you want to know more. Okay. Another question by Hélène: will the R and Python tool be open source? So that's a good question, and thanks. It shows that there is some interest in the tools. So right now they are only open to the partner of the project. We will be considering with the partners whether we want to open, let's say, some open source version or not. It is on the table right now, and we haven't decided yet. We will try to do so within the next months. And but the more, let's say, request to get access to the tool, the more we think about it. Okay, maybe I don't know. Maybe Will or Nicola, you want to add something to the question I just answered? Or we can have more questions if you want. Feel free to ask more questions. And otherwise, you also have our contact if you want to extend the discussion later on. Any other questions? Can wait 1 or 2 more minutes, and otherwise we can close the meeting. So as I mentioned, we have this next phase that will be launched in October 2026. We are currently defining the scope of the project, so we are still open to new partners in this, especially new industrial users of the result, and the tool will be much welcome. And we can still adjust the scope that is, as I mentioned, now focused on orographic and bathymetric effect and uncertainty, so that we can improve further the methods. Okay, so if there are no further questions, then we can stop here. I would like to thank everybody for the discussion and the presentation, especially Will, Nicola, and Paul, and also Mélusine Gaia from FEM, who organized the webinar. And I wish you a nice day, and do not hesitate to stay in touch with us for more questions and discussions.